Okay, here I have an instance of Atomik running on my computer. We have also a FHIR server running on the same computer. The FHIR server acts as a facade over the openEHR server. In the openEHR server, Atomik, we have some health records, we have some people loaded, we have some people that are patients and others are healthcare providers. And we have a query for patients, for instance. We have a query that looks for patients by name and partial name. So we have this query here that can search by first name or last name and accepts variables. So we are using two variables to search for, and those variables can be partial names because we are evaluating them or comparing them against the value by a similar operator. This is the kind of the like for SQL. So we are kind of doing value like this variable. So it can be a partial name, a partial last name. If we test this query in Atomik, you can see that we have these two fields to enter the variable values. So we will do something like pow. I'm doing this because this is, for instance, when you want to do a search and you have a single field to enter a value and you want to compare that field against all the fields that you want to compare that you have in your database. So for instance, if I have a single field to search for and I enter this POW text, I want that POW to be compared against the first name, the last name, could be also a second name, middle name, the mother, maiden's name, etc. Yeah, so in this case, I will compare the same value against two different fields. And this, when I run this is testing on the same server against the data that is loaded, and it is looking in the whole database for those two values. I'm getting some records. This is the minimal summary, I would say, of the items that actually matched this condition. If you want to retrieve the data, you can just click on that and we will see 1, 2, 3, 4, 5 results with the data. So we should receive instances of person as the result of this query instead of the summary. And there we have person. If we check the name and last name fields, those should match. For instance, identities here. So the first name is Paulo, so that actually matched the partial value, so that matched there. So I can search in the other results that actually matched what we asked for. The second result is pound, so that also matched. We have Paulette, also matched there. We have another pound there, and we have a Paulino there. So all matched the first name. If the first name didn't match, we would match the last name. Yeah, so that's when you want to just execute a search, that this search is stored and has a UID. So we have this search has this identifier, and we can use this identifier to execute the search through the REST API of Atomik, yeah, the openEHR server. But now we want to do something else. Instead of executing directly through the openEHR API, we want to execute that search through the FHIR API. So we would do something like that. We have a different server, so we are running Atomik in the same machine, but in port 8090, and the FHIR server is in port 8080. Yeah, and the path is FHIR patient, blah, blah. This is a get, so the body is empty. We are not using authentication right now. We could add authentication, and we are mapping that same search against FHIR. So what we are doing is we say, let's compare the name, and when you do name in FHIR, you want to compare against all the fields in the human name of a patient. If you know the FHIR model of the patient, the resource, you know that for the name is a human name, and human name has a lot of fields there. Yeah, has a given, family, etc. And when you search by name, you're actually comparing against all the fields inside that human name type. Yeah, and when you do column contains, you are actually comparing the partial value. Yeah, so you want to compare again, we will use the same value to compare against the name, and that internally will be mapped to that openEHR query. So this will be mapped to those two variables that I showed you on the openEHR query internally, but will receive this request in the FHIR server. The FHIR server will do the translation to execute the right query by ID. So there is a mapping between this URL and the parameters and the exact ID of the query in Atomik. And we can add also pagination here. So we can add count. This is the maximum number of results that we want, and offset. This is to ask for different pages. So first we will ask, for instance, 0 to 10. The next one will be 10, 10. The next one will be 20, 10. Yeah, so the count is kind of constant, and you will move the offset, actually adding the count on each next page. In this case, we will have 5 results as we saw in Atomik. Yeah, and if I send this search, this is actually internally received by the FHIR server, doing the translation to the exact query, using the openEHR REST API client to connect to Atomik. Atomik retrieves the same result as you saw previously through the API. The client parses back the openEHR response. The FHIR server takes that response and maps back the openEHR person to a FHIR patient resource. And in their response, we have a bundle that is actually a list of stuff. Yeah, is a search set because it's the result of a search structure. In the entry, we have an array, and that array contains the resources. So we have patient, for instance, here. We have the ID here. The ID in FHIR is the object ID in openEHR. And we added the other 2 items from the openEHR version ID. openEHR version ID in openEHR has 3 fields: the object ID, the system ID, and the version 3 ID. And this is the system ID. It's mapped to the metadata source, and the version in openEHR is mapped to the version ID here in the metadata. So these 3 fields actually mapped to one identifier in openEHR. Then we have, for instance, the documents of that patient mapped back from openEHR identifiers. The name of that patient mapped back from some DB text fields to the human name structure in FHIR. Also, we have emails and phone numbers also mapped back. We have, for instance, this is the model. So we have a person that has documents that are identifiers. As I said, those are mapped to identifiers in FHIR. So this identifier is actually one openEHR identifier. Yeah. From here, we have, for instance, sex or gender of the patient, and this is the administrative gender or sex that has a code that is mapped to an extension here that actually has more codes than the standard gender value set in FHIR. So we needed to add an extension, but telecom items are pretty standard. Birth date, pretty trivial, is mapped from an openEHR DB date. In the model, we have also the addresses of the patient. We have marital status. This also maps to codes defined in the corresponding archetype, openEHR archetype, to a value set in FHIR. So we have that mapping, and we can have more fields here. Yeah, but these are the basic fields for the patient. And here we have 1, 2, 3, 4, 5 items in the response, and there is a count somewhere here that says 5. Yeah, so this is giving exactly the same information as we have in the result from Atomik, but in the FHIR format, and is accessed through a FHIR API. So we can do this kind of query translation. So we translate the query forward, and we then transform the results back from openEHR to FHIR. And we can also create data through FHIR that is mapped forward to an openEHR resource, then stored in the openEHR repository. Yeah, we can do both. So this is just a small demo of what we did. There are some extra fields that we need to map, but it's kind of trivial from now because we have some the more complex things are really things that are extensions, for instance, that are not in the basic resource or in the base resource that we need to actually extend something. Another thing that can be difficult is mapping codes, and sometimes you don't have the exact codes, so you end up or modifying your original openEHR model or just creating an extension like in gender. In gender, we actually needed more codes, so we needed to extend that to have a different kind of field for the gender than the standard one. But once you start doing those extensions, it's pretty easy to know and to understand what should be mapped directly to the base resource and what should be kind of an extension. And on top of that, when you have a set of extensions, you can create a small profile that has all those extra codes and fields there. So it's easy to then map, for instance, one profile to one openEHR template. that's the easiest way to do this work. So we are doing this for a client and it's been fun. Just wanted to share that with you. If you have any questions, just let me know in the comments. Thanks.